China produces about 2 million tons of graphite. The only large natural graphite producer outside China is POSCO in Korea, 80,000 tons. We have a 2,000 ton plant in Karnataka. I would say that's the largest ex-China synthetic graphite plant. So you're talking 2 million and 2,000. They're totally different ends of the spectrum.
18 to 24 months it takes to qualify a customer minimum.
18 to 24 months, it's more like 4 to 5 years.
So why India as well as US also, right? Both. Why not only from India to supply to US?
But it was our customer, the Korean cell makers, the Japanese cell makers that said, look, if we're working with you, we have an obligation to buy in the US. Because of the IRA and now the other bills, you're making large investments. And if I was a cell company investing 2,000-3,000 crores in a gigafactory, I would sit and wonder, is there something in my supply chain that one day can cut me off? This is not an industry that I go license, build a plant and supply. Because by the time I build a plant, technology has moved, customer requirements have moved.
PLI scheme is kind of sufficient to develop the entire value chain.
Anode has different requirements, cathode has different requirements, electrolyte has different requirements. So to come up with one scheme is actually very, very tough.
As per one of the latest reports by 4C Advisors, cathode is the largest cost contributors in this cell manufacturing, followed by anodes and separators, then electrolyte, current collectors, and housing. Cathode contributes around 35 to 45% of the total value, followed by anode and electrolyte with 10 to 15%, then the current collectors, housing, and electrolyte at 10%. As cathode manufacturing faces a lot of challenges for the localization in India, anode and separators becomes one of the candidates for early level of localization. If you look at the cell manufacturing status in India and we talk about the localization levels, 10 to 15% is the local value addition what India is doing at this point in time, which is expected to be around 25 to 35% by 2027 and approximately 45 to 55% by 2030. Today, we are going to find out the opportunity and the challenges around anode manufacturing in India. And we have Mr. Vikram Handa, Managing Director, Epsilon Carbon and Epsilon Advanced Materials Private Limited, to deep dive with us. Thank you very much, Vikram, for joining the show today. I think we are all aware about the situation of cell manufacturing in India and how the entire ecosystem is evolving. And I just wanted to begin with, understanding about the Epsilon Carbon's journey and then how you decided to start, Epsilon Advanced Material and why material business.
So, thank you. Thank you very much for having me on the show. So I started Epsilon Carbon about 14 years ago now. 2011 is when I really started the company. But I still look back and say 2017 is when we really kicked off. We started off as a regular coal tar distiller, forward integrated into carbon black. So Epsilon Carbon is a larger B2B chemical business. We have about 2,000 customers globally and kind of growing organically every few years. We add capacity. So that's been his journey. And we look at that by 2030. Epsilon Carbon itself should become a 10,000 crore company.
Wow.
And it's well on track to do that with our facilities in Karnataka and Orissa.
Great.
2019 is when we started Epsilon Advanced Materials. It was a focus on battery materials. So I didn't want to just pick a battery material and say we're doing anode or cathode or something like that. So I just looked at it as advanced materials.
Right.
It's a forward integration of our parent. So in our parent, Epsilon Carbon, we make a product called coal tar pitch.
Right.
We developed a technology and patented to make something called meso coke, which is a unique coke similar to petroleum coke, but gave unique benefits on anode performance. And then we kept forward integrating. So from coke, we went to synthetic graphite. And over the years, now we are a large synthetic and natural graphite player.
Right.
And 2024 is when we decided to move into the LFP cathode space as well. I felt there was a lot of synergy between the businesses, and we were lucky to get an acquisition in Europe. And now today I look at us and we are a anode and cathode player, and that's where Epsilon Advanced Materials sits.
Vikram, this is really very, very interesting because, you were doing the forward integration of the business which you already had. I just remember my conversation in 2012-13 with one of the companies. That time, many people actually announced that they are going to come up with the lithium-ion battery manufacturing in India. And when I interacted with them, they were asking questions such as, can we get anode within 15 days? Can we get cathode within 20 days? Those kind of questions. But I think this if you have existing understanding, existing business, and then based on the learnings, if you come up in the business, I think that is more logical in nature.
Yeah.
So, Vikram, whenever we talk about, anode, we really need to talk about the graphite, right? And when we talk about the graphite, we cannot ignore actually the massive capacity building which China has done. More than 70%, I think, in terms of the production capacity, more than 90% of the processing technology. You also always highlight that production or
Yeah.
the material availability is one thing, but the processing technology is also very, very important, right? So in that sense, China anyway has a lot of control on it, right? So then why this became, one of the interesting area for you? What makes your graphite special for the industry? If you can just
Yeah. So actually, when I started understanding graphite, and I had no idea,
right.
and I visited Japan a lot,
Mm.
and I would say 2000 and you know 15, 16, 17, 18 even,
Mm-hmm.
like you felt like Japan will be the source of this
Yeah.
because cell technology sat there,
Mm-hmm.
and Korea a little bit, but China wasn't spoken about so
Right.
much. And that threat of overcapacity in China wasn't a threat 10 years ago.
Mm.
But the Japanese, I felt, saw it coming.
Yeah.
And they kind of withdrew to say,
Mm.
look, we are not strong at industrializing. We cannot compete on scale with the Chinese. And the market is growing too fast in China.
Mm-hmm.
And they kind of, while they had great tech, they
Yeah.
kind of closed up to
Yeah.
be the supplier to the world.
Mm.
Companies like Hitachi said, look, we're going to move out of this space.
Right.
So at that time, there was a conscious effort that natural graphite will be the winner.
Mm-hmm.
So there's natural graphite and synthetic graphite.
Right.
Natural graphite is made out of flake graphite that comes out of the earth, and synthetic graphite is made out of
Mm-hmm.
either petroleum coke or meso coke that we
Right.
manufacture.
Mm-hmm.
So the focus was always natural graphite, and the world took a view that
Mm.
natural graphite is amply available,
Mm.
and so this will be the winner.
Mm.
I think you have to understand the technicality of graphite. It's a very high safety, fast charging,
Right.
long range kind of product that defines that in a cell.
Mm-hmm.
And not everybody understood that.
Right.
From a cost point of view, the
Mm.
cathode costs more.
Right.
So you'll always see customers first say, look, I need to figure out my
Yeah.
cathode. I need to tie in a supplier. I need to
Right.
control that cost.
Mm-hmm.
And they always ignored anode because it's about 10 to 12% of their cost,
Right.
but 25% by volume.
Yes.
And they just kept looking at China and said, look, it's all available, it's all available. Let's keep focusing on cathode.
Right.
In the meantime, Chinese kept building capacity.
Mm.
This was one of the new energy sectors that the government was promoting.
Mm.
So investment, subsidies,
Mm.
all flew in.
Yes.
Today, China produces about 2 million tons of graphite, to
2
give you a
million
scale,
tons.
right?
Mm-hmm.
The only large natural graphite producer
Mm.
outside China is POSCO in Korea,
Mm.
80,000 tons.
Mm.
But when you talk about synthetic graphite,
Mm.
we have a 2,000-ton plant in Karnataka.
Mm.
I would say that's the largest ex-China synthetic graphite plant. So you're talking 2 million and 2,000. They're totally
Right.
different ends of the spectrum.
Right.
So the challenge lies in technology, in
Yeah.
scaling up, in industrializing, commercializing.
Right.
But what happened in the last 3, 4 years, people started pivoting more to synthetic
Yes.
graphite over natural. And now it's very apparent
Mm-hmm.
that synthetic graphite will be the winner, at least for the next decade,
Mm.
when it comes to graphite anode materials because of cost,
Right.
because of high performance.
Mm-hmm.
And as you move more and more to LFP chemistry,
Mm.
you need a synthetic graphite. So LFP doesn't work well with natural graphite, which
Right.
not many people know.
Right.
So you can talk LFP, and cost and fire safety,
Mm.
but that means you need synthetic graphite with
Right.
LFP to get that cell performance.
So is synthetic graphite also favorable for improvement in terms of your battery performance, your charging, etc.
Yeah.
And what's about is the scenario about availability? Like for example, initially it was assumed that natural graphite is going to win the race, but as you said, now synthetic is going to kind of be the mainstream.
Yeah.
So
So what mature customers actually do is that they blend it.
mm,
So they have a blend of natural and synthetic. It could
Mm.
be 50-50, it could be 70-30.
right.
That is their secret recipe.
Mm-hmm.
Right? We are one of the few companies that does both natural and synthetic.
Right.
But synthetic is obviously our forward integration, and that's where
Mm.
most of the market demand comes from. And so we focus on synthetic graphite
right.
more. So it's not like one is a winner or loser.
Right.
Customers need both.
Yes.
They usually go to two different suppliers.
Mm.
In our case, they come to us for both products.
Mm.
synthetic graphite you can fine tune.
Right.
Let me say you can customize more easily
Right.
because you're working on carbon elements, and at
Yes.
the end you convert it to graphite at 3000 degrees.
Hmm.
Natural graphite has certain limitations because you're digging it out of the earth and it comes with a certain,
Right.
say, carbon structure or graphite
Hmm.
structure.
Mhm.
So then you have certain limitations, but each has a pro and a con.
Right.
You have to really marry it in the cell chemistry that a cell customer
Right.
has.
And there are talks about silicon based anodes also, right?
Yeah.
But I think as of now, we can take a fair guess that the synthetic one is going to be mainstream for
Yeah,
next
So
decade.
silicon is definitely very interesting, and we have been working on it for 2 years also.
Mm.
But people are not aware that silicon will not replace graphite. Silicon will complement graphite. So it
Okay.
could be 5%, it could be 10%.
Mhm.
Today, I would say most things are 5 to 10%
Mm.
already
Right.
in cars and consumer batteries.
Mm.
But it will never go to 30, 40%.
Right. Right.
So it's good to work on silicon, and
Right.
I think it's important for the industry to move up the, say, performance value chain,
Right.
but it'll never replace graphite. Someone still needs to
Okay.
make that
Mhm.
synthetic graphite 90%.
Yeah. Okay. So you talked about, right? You already have built a facility about 200,000 tons.
2000.
2,000 tons, and there are definitely plans, right? And I think 2,000 tons, the plant which you have built is mainly for customer qualification, if my understanding is correct.
Yeah.
This customer qualification, I want to go a little deeper and understand in a better way, because I was reading and I understood that around 18 to 24 months it takes to qualify a customer minimum, right? Mainly because of the testing requirements from the cell manufacturers, if my understanding is correct.
Yeah.
So how can a company be so patient about 24 months? And I just wanted to understand this process a little detail, what it takes and how you qualify the customer
Yeah.
eventually.
So three products are very important for customer cell performance: anode, cathode, and electrolyte.
Yes.
They're highly technical products.
Yes.
These are not off-the-shelf products like nickel sulfate or lithium carbonate,
Mhm.
where you just hit a purity and it's good to use.
Yeah.
So these are three products. They require a long, say, qualification journey,
Mm.
and it's unfortunately I wish it was 18 to 24 months. It's more like 4 to 5 years.
4 to 5 years.
Yeah, so you need to be very, very patient.
Mm.
I can tell you a little bit about our journey,
Please, please.
right? So when we started in 2021,
Mm.
we were giving customers from our pilot plant 1 kg samples.
Okay.
So we start off and we say, look, we have product A, B, and C,
Yeah.
generic specification.
Yes.
Which one do you think you like?
Mm.
He said, okay, give me product A and B.
Mm.
So he takes A and B, he
Mm.
puts it into a coin cell.
Mm.
3 months later, he comes back, says,
Mm.
look, I like A, but these few parameters need to improve.
Mhm.
Okay, he gives us some feedback. We start improving product A. So he might say, look, I need capacity 355.
Mm.
I need cycle life,
Mm.
3C charge this much. I need lithium plating so much.
Mhm.
So certain parameters, we don't understand really what he's doing,
Yeah.
because he has his cathode, his electrolyte, his so many secret parts.
And things are also changing much faster, right? Maybe they are also improving.
Yeah. So
learning.
they're always pushing the boundary.
Yeah.
They ask you for this,
Yeah.
and then they say 3 months later, but I just want a little bit more,
Right.
because it gives them a cell benefit.
Right.
So then you go back to them.
Mm-hmm.
So every time he asks me change something,
Mm.
I have to go back. I have to make a new coke.
Mm.
I have to make a new graphite. That's about 2 months.
Mm.
I have to make a cell in my lab
Mm.
and generate data. That's another 2 months.
Mm.
Right. Then I give him the product, saying, look, it performed like this. He takes another 3 months.
Mm.
So now it's been
Right.
7 months
Yeah.
since he told me. He comes back and says, okay, but now change this.
Okay.
Okay. I start again.
Right.
But this time I've learned a bit more. So 7 months, it might take me 4 to 5 months.
5 months. Yes.
So this iterative journey continues
Mhm.
at a kg scale, 1,
Okay.
2 kgs, that's it.
Understood.
I can say about 3 years have gone by and I've just been supplying kgs.
Mm.
Then he says, okay, now you 1 kg sample, all 8 of 8 parameters have been met.
Okay.
Now give me 500 kgs or give me ton. He
Mm.
says, you can do great things in a lab
Mm.
or a small pilot line. But
Yeah.
if I'm going to take a lot from you, I need to see commercial scale.
Right.
So this is where we build a commercial plant, which we
Mhm.
call a customer qualification plant, EAM1,
Yeah.
where we produce at ton scale.
Okay. Mhm.
So now we produce 5 tons. So the whole process
Mhm.
is much larger. So imagine a 2000 ton plant just making 5 tons.
Mhm.
But that proves to the customer that our technology is commercialized,
Right.
it's scaled up, there is no risk in technology scale up. Then he also commits a lot more. He puts it into a pouch cell, a multi-layer pouch cell. So he's investing a lot more in taking
Yeah.
trials
Yeah.
as well. Then he gets the confidence.
Right.
So that
Right.
takes another 18 months. So basically, from the day I contacted the customer,
Yeah.
it's been 4 to 5 years, and now he says, "Yeah, you're qualified at a certain scale." So what we did was that when we were at pilot scale and still qualifying, we started building a commercial plant. So that itself takes a year and a half to 2 years.
Right. Right.
So we built a plant without having a customer.
Yeah, that's what is like interesting, right? You need 4 5 years, right? A lot of time, a lot of resources, a lot of investment without even clarity about whether you are
Yeah.
going to have a customer or not. At the same time, the customer is also putting a lot of money, but maybe he's exploring many more
Yeah.
options. So that kind of
So,
investment has gone right.
so that yeah, huge investment has gone in by us over the last say now 6 years. But that was I think that was the moment that defined us also. That when we crossed this 1 kg sample and the customer said, okay, you qualified, now give me 1 ton. I said, I can give it to you in 2 months.
Yeah.
Any other company would have signed an MOU, gone
Right.
and done a fundraise,
Yes.
and said, I'll take you 2 years to come back.
Right.
By then, he's moved on.
Yeah.
By then, he's found another supplier or he's not interested to work with you.
Yeah.
So, customers also saw our commitment to commercialization, industrialization,
Yeah.
and we could continuously continue that qualification journey.
Right. Right.
Also, we've invested in a big cell lab. So, all material characterization, coin cell, pouch cell, multi-layer pouch cell. So we're able to replicate what customers do also internally.
Yeah.
The difference comes, the first customer took us 5 years.
Yeah.
The next customer took us 2 years because we have learned.
Right.
And now we know what customers expect.
Yeah.
So the qualification journey, as you go iteratively, gets shorter and shorter.
Right. Right.
And then comes the building the larger plant.
Right. Right. Yeah, I'm really glad to understand that. So you have the customers which you have already qualified, which means you will be supplying them at commercial
Yeah.
level, right?
So where we are today, we are say past sample C with customers
Okay.
at ton scale. Now there's no more qualification left. We are negotiating commercial contracts with customers.
Right.
To build a first phase 30,000 ton plant in India. 30,000 can cater to 30 gigawatt hours.
Right.
And in the US, a 30,000 ton plant also to cater to 30 gigawatt.
Right.
Then we will double capacity and increase India to 100,000 eventually.
Right. Right. Yeah. So by 2027, I think the 30,000 tons.
So both our projects we've done engineering. We have done our permitting. So in US, we're the only company to have a permit for building a graphite plant. No one else has managed to get a permit even. And now the idea is that in the next 6 months, we break ground and we start construction. It will take 18 to 20 months.
For your
US and India.
Both.
So we aim to build both in parallel.
Right. Right.
For different customers.
Okay. So this is interesting, Vikram. I want to understand, like for India, you said 30,000 tons by 2027 and announcements are like 100,000 tons by 2030 is the plan.
Yeah.
If I look at the US announcements which you have made is like $650 million investment, 30,000 by again 2027 and again 100,000 I think by 2030 is the
60,000.
60,000 is the plan which is there in the public domain from where I'm referring these numbers. So why India as well as US also, right? Both. Why not only from India to supply to US, or why not only because customers are only in United States maybe at this point in time. So why don't you make a plant in US and then cater to those customers? Why you are tapping both the locations?
Yeah, so I think India is our home ground.
Yeah.
We have a lot of comfort in building in India. We are backward integrated. And I truly believe in building in India for India.
Right.
The challenge in India is it's very difficult to time the market.
Right.
Right. And I need to build a 30,000 ton plant, means I need a 30 gigawatt hour customer.
Yes.
Now, if you read reports, 30 gigawatt should have happened by 2025. Then there's some speculation 27 and 100 gigawatt hour by 2030.
Yeah, most of the report talks about 100 gigawatt by 2030, but
it's not happening.
Yeah.
Right, but we want to build. So what's the most important thing is customer.
Right.
So where is our customer today? Our customers in the US.
Right.
So we were clear from day one, we will build in India. But it was our customer, the Korean cell makers, the Japanese cell makers that said, look, if we're working with you,
Mm-hmm.
we have an obligation to buy in the US
Right.
because of the IRA and now the other bill. So
Yeah.
they are very focused that you need to be a company that builds in the US.
Hmm.
So that is what took us to the US.
Okay.
In early 23, we looked at 100 sites. October 23, we announced a site in North Carolina. And I think a 60,000 ton plant will cost us much more than $1 billion as we have done engineering and built.
Yeah.
But the idea is that to build that first 30,000,
Mm-hmm.
our plant in Vijayanagar is largest ex-China plant and that's 2,000.
Yeah.
So no one has built one of these plants we're attempting to build.
Yeah. I mean, there is nothing out of China, honestly.
There's nothing, no
Yeah.
synthetic graphite.
Yeah.
So every time you read a headline and it says
Yeah.
LFP, LFP, someone should wonder
Right.
where is that synthetic graphite going to come to complement that LFP?
Right. Right. There is some restriction and then a lot of disruption
Yeah, yeah,
happen around supply chain. So how do you plan to integrate, both the plants, India and US? So whether do you plan to supply from India also to United States if there is a favorable condition, or like this capacity which which you are going to build in India, 100,000 tons. I think there will be limited domestic supply, so you need to really focus on exports, or how?
So the idea is to build the first 30,000 tons. Out of the first 30,000 tons,
Mm.
about 10,000 tons we have already committed to a international customer,
Already.
right?
Mm.
So that's left with 20,000.
Right.
Out of the 20,000, we're discussing a contract of 15,000 with a US customer.
Okay.
That leaves me 5,000.
Mm.
This 5,000 I will keep exclusively for Indian customers
Right. Right.
because I believe Indian customers will be really large eventually. They will all start off with 1 gigawatt.
Yeah.
They also have to learn, just like
Yeah.
we have learned. They also
Right.
need to learn. There'll be difficulties. They will ramp up.
Right.
So if I can enter the supply chain of an Indian customer with 1,000 tons,
Mm.
when he goes to 5, he goes to 10,
Mm-hmm.
I will grow on his back. So I think my next phase of Indian growth, the
Right.
30 to 60 journey, hopefully will be completely dedicated to Indian customers.
Yeah.
But the first phase, I'm committed that I want to enter Indian customer. Now, I can't necessarily compete with Chinese prices.
Yeah, that's what I wanted to ask, because if you look at the Indian OEMs or the battery manufacturers, cell makers are also, I think, a lot of in the learning phase, right?
Yeah.
The way companies like Epsilon has been in the learning phase and developing. So in many of the times, what they do, they just compare on the prices, right? And the kind of on your one of the previous talks I was listening, you have gone in detail and talked about how it is very difficult to compete on China because they are getting the R&D resources, they are getting the infrastructure built by government, so they can definitely go lower on margins, and even they are not making margins as per
Yeah, yeah.
your understanding. So but Indian customer will always look for price competitiveness. So I think they also need to understand, in case they are looking for a long term supply chain stability, that probably they also need to come out of this lowest price game. Otherwise, the dependency will always be there on China. So
Yeah.
your opinion on that?
So definitely Indian market is price sensitive, right?
Yeah.
But I understand where they're coming from. Because
Yeah.
if I'm a cell maker,
Yeah.
I also have to compete against a Chinese cell.
Yeah.
I have no protection.
Yeah.
So if I have to make a $50 a kilowatt hour cell in India,
Yeah.
and I also don't have a scale,
Mm.
I don't have a 30, 40 gigawatt hour cell factory.
Yeah.
I'm smaller, 1 or 5.
Mm-hmm.
How do I compete against a Chinese cell in India?
Yeah.
So now he says, look, if I don't buy cheaper raw materials,
Yeah.
how do I
Compete.
how do I compete in my cell market? Otherwise, a customer will keep importing the cell from China or Korea.
Yeah.
So I understand where he's coming from, but I think it's also you are making large investments. And if I was a cell company investing
Yeah.
2-3,000 crores in a gigafactory,
Mm-hmm.
I would sit and wonder, is there something in my supply chain that one day can cut me off?
Right.
Right. And I always give this example.
Mm.
If you look at any other critical mineral or battery material
Mm-hmm.
that has to go into a cell, there are always alternates. I can pay 5% more and buy lithium from Chile
Right.
versus China. I can buy nickel from Indonesia.
Yeah.
I can buy a cathode from BSF or Umicore or Korea, separator, electrolyte. Everything there's an option.
Yeah.
It's only graphite that there's no option.
Oh.
Right? Because you'll always keep going to China.
Yeah.
And the messaging that has come in the last 18 months on graphite
Mm-hmm.
is identical to rare earths.
Okay.
Like first we will put a restriction.
Yeah.
Then there's a restriction on, we will choose who to give a export permit to.
Mm-hmm.
Then they're talking about restricting technology.
Mm-hmm.
So as the messaging is coming,
Mm-hmm.
some customers are realizing, look, I need to de-risk. Cost aside, I need to de-risk.
Right.
So I tell Indian customers, I said, look, qualify us and buy from us.
Yeah.
If you have a 5,000 ton requirement, buy 1,000 tons from me. I don't want 5,000 tons.
Right.
Keep buying from China while it's cheaper.
Yeah.
But the day he switches off,
Yeah.
you come to me, I'm not in your supply chain, I'm not qualified. I have a plant that is supplying someone else because I have a contract with him.
Right. Right.
What am I going to do? So whether it's a customer or whether it's the government also, I think it's about bringing awareness that
Yeah.
this is a critical thing which can slow down the adoption and the industry.
Yeah. I think this can be even much bigger impact than graphite because it's completely at one location, right? For other materials, at least you have options.
Yeah.
So you mentioned, right, the messaging part, I wanted to go a little deeper so that we understand, the policy. I think policy making has a very unique trend for any particular country, right? That is how given this geopolitical situation and other situations, they take decisions. So, for example, China has invested huge amount, right? So they also need to take care about their interests. So I think December 1st in 2023, they talked about the export permits of graphite, and that included even the spherical graphite, which goes for your anodes for electric vehicles. And then very recently, in July 2025, they talked about restrictions around cathode materials. So bringing the technology, IP, or processing is very, very difficult now for any other country.
Yeah.
At the same time, United States has put up 160% import tariffs on the graphite-based anodes. So these things are like really changing very fast. But if I look at your strategy, that's kind of fitting perfectly, at least at this point in time, right? You have a diversification in United States, and probably there can be very high demand. So how was the strategy making? I wanted to understand strategy making, and before that you can touch upon the overall scenario of restrictions, the taxes, etc.
So I think it's about listening to the customer.
Yeah.
And the customer saying, look, I need you to be in the US.
Yeah.
And us being positive that you can always say that, look, US building is expensive. It won't be the same price as Chinese or Indian product.
Yeah.
But the fact is you have to move ahead.
Yeah.
A lot of our peers took contracts in the US in 24, in 23 and said, oh, 2 years SOP and I'll supply you graphite. No one realized it takes 18 months, 24 months to permit a project.
Right.
Because the industry is never built.
Yeah.
Okay. Other than, say, labor shortages or cost escalations in the US, like no one has managed to permit. And the fact that we permitted means something is right in our technology that we have identified and worked on.
Yeah.
So I think one was that I always looked at the business and said, first step, I have to qualify.
Yeah.
Because if I can't make what the customer needs, there is no business. Next, I have to permit the project to de-risk timeline, and I have to do my engineering to know the cost.
Yeah.
If I've done these three things, the day I sit in front of a customer, I'm confidently able to get into a contract.
Right.
So these three things, we did both in India and US. So that we've been investing. There's a large team that sits behind this.
Right.
Our engineering center that has done all this work in 2 years. So we're confident that when we're talking with customers to get into these contracts. So our strategy was, look, if we don't get there, we're not going to get an offtake.
Right.
So, going back to what I was talking about qualification, I think one thing is very important to understand because a lot of people think that you can just build this plant and, turn it on and like customers need it and the market size is so big. I can tell you, like, written for sure, the day you decide to enter battery materials industry, it's 10 years to cash flow. Guaranteed.
Right.
So the day I said I'm starting anode, cathode or electrolyte, you're going to take 10 years to get cash flow. There is no way in 3 years you can see money come in. So that's one benchmark to keep in mind whenever you're making these investment decisions. So the challenge now becomes with China restricting the export of technologies.
Yeah.
They obviously have built a lot of capacity on battery materials, on cell manufacturing, and even cars.
Right.
So they're very happy to supply cars to the world,
Yeah.
or even cells to the world.
Yeah.
But they don't want like this supply chain getting developed everywhere and everyone localizing. Now today they have restricted the export of lithium processing and LFP. So what happens? What happens is that a company that was planning to produce cathode and was going to China for licensing,
Right.
you don't have access to that. Now, how do you develop your tech? It's a 5-year painful journey that we have done on anode.
Yeah.
And you have to own your IP. I've realized this over time. This is not an industry that I go license, build a plant and supply. Because by the time I build a plant, technology has moved, customer requirements have moved.
Yeah.
And if I'm not the innovator, if I'm not the guy owning the IP, I will always be behind.
Yeah.
So this is not like oil and gas or other industries where you go get a very proven license, you pay a fee, you make a huge investment,
Right.
and your product sells. You have to own IP. So we're lucky actually that the tech center that we acquired in Germany came with 120 patents and a very mature LFP, LMFP technology, which we are further progressing and developing continuously with the team's experience.
Right.
And then the idea is to build a large plant in India.
Yeah, I think this is important. I also see a very clear difference in how the traditional IC engine supplier development has happened in India, as well as how it is different in the electrification. So, if you look at traditionally how auto component industry in India has operated, it that they talk about their value proposition in terms of money and access to land and access to the customer, never really on the technology. But very much difference here is you need to have your own IP, your own technology if you're operating in very critical areas such as anode manufacturing, cathode manufacturing.
Yeah.
So what's your plan with the cathode manufacturing? Because these things are really, I mean, beyond imagination kind of thing, honestly, to me, because I have been tracking this industry since long, that Indian companies coming up in anode manufacturing, then cathode manufacturing, building commercial level plants. So how do you plan to build the cathode manufacturing in India, and how much time it is again going to take for customer qualification? Is it in the pilot stage or a commercial stage? The company which you have acquired, how it can help you?
Yeah. So we acquired a tech center from Johnson Matthey in early 24. So a lot of IP and a 300-ton pilot plant. So actually what that gives us is able to produce samples at mass scale.
Right.
And we were already qualified with a lot of customers. So we are continuing supplying customers. Today our cathode LFP cathode material is in actual two-wheelers operating in Asia.
Right.
So customers are taking it, making cells, and it's operating.
Okay.
Now China has moved on. When we acquired the facility, we were at Gen 1.5 cathode material, LFP. We have progressed now to Gen 3.
Okay.
The market is at Gen 3 today. What you will see at a Tesla today is a Gen 3.
Okay.
The market in China has now moved to Gen 4. They just started qualifying. But we are now looking in Gen 3 and Gen 4, there are certain differences in performance. So this, what the Chinese have managed to do is increase capacity in LFP, so Gen 3, Gen 4.
Okay.
So you start coming closer to NMC. So you actually are like 5% below NMC performance, but 30% lower cost. So then you say, okay, look, that makes sense.
Yeah.
And especially if you pair that with synthetic graphite,
Right.
you can get a very good performance in a cell.
Right.
So our goal is clear. We're going to build a Gen 3 plant to start off. Luckily, cathode is much lower capex than anode.
Oh.
And it's a much simpler process plant also. Not so many steps and not so much power hungry like a anode business.
Right.
So we look to build a 100,000 ton plant in Karnataka. First phase will be 30,000. So interesting. I got a call last week from a US investor. He says I'm an investor in a large lithium project in the US, and we are going to produce 25,000 tons of lithium carbonate early next year. And would you like to buy some? I said, it's okay. Means we can look to buy, but we can also buy from China. We can buy from Chile.
Yeah.
There are a lot of options for lithium carbonate. So what's the advantage? He says, while talking to me, he asks me, he says, I'm trying to sell you this.
Yeah.
But I want to ask you a question. Where do you think this 25,000 tons will go? I said, I don't know. I guess in the US. He said, there is no CAM manufacturer in the US. You have 3 or 4 lithium projects that are coming up in the next year, 20, 40,000. It is either going to go to, say, BSF or a POSCO, or it's going to get shipped to China, become a cathode and come back, or it's going to go to Korea, become a cathode and come back. So why is this CAM industry not developed in the US? I mean, today everybody talking LFP, nobody wants to build an NMC plant in the US.
Yeah.
So that goes back to who can build a LFP plant in the US. So I think it's again important to hear the customer.
Yeah.
But today the messaging in the US is, look, like Ford or LG, we need to move to LFP. We're moving to LFP. But where will the CAM come from?
Yeah.
Who has technology?
Yeah.
Who can build a plant in 2 years?
Yes.
A lot of people in the US are still at lab.
Yeah. And cathode being a very large cost contribution, right?
Yeah.
Also becomes
So
very,
that
very
sends
important.
almost the whole ex-China industry back 5 years.
Right.
Because you're back in the lab, then you go to pilot, they'll move ahead, you need to catch up, and you need to industrialize.
Right, right. And let's talk a little about, US import duties of 50%, which are imposed on India.
Yeah.
Is there any linkage with the battery or the anode cathode supply chain, and how it is going to impact companies which are putting facilities in India, and in case they are targeting to export?
So if you ask me, that is the most necessary thing for Indian battery supply chain, India battery material supply chain. What we need and I'd speak hopefully from an industry-wide opinion,
Yeah.
is we need a customer. And in some cases, a larger customer.
Yes.
Because we have to build to scale.
Yeah.
And that customer today sits in the US.
Yeah.
The US is protected from China because of their tariffs.
160%.
So there's a good chance for Indian company to supply anode, cathode, electrolyte, foil, separator, all that to the US market, in my opinion. So the US has identified certain things as critical minerals.
Yeah.
And critical minerals actually are exempt.
Yes.
Even between the US and India,
Mm-hmm.
like the status that is today.
Yeah.
I've been lobbying a lot that somewhere the US and India need to align to say, look, India will be a preferred partner when it comes to battery materials. What that will do is that will bring capital, that will bring technology into India. People will build plants. They'll say, look, this is a better low capex, low opex place to build, supply the US market. But what will happen in 2-3 years is the supply chain will develop. Eventually, the Indian ecosystem will benefit.
Right.
I think this is a much more important trigger than a PLI scheme.
So, what's your opinion on the PLI scheme? Right, we talked about 30 gigawatt, that 50 gigawatt companies have been allocated. They are building the facility. So, do you think PLI scheme is is kind of sufficient to develop the entire value chain, or do we need to have some separate PLI for maybe materials like anode, cathode, separators, electrolyte? Question number one. And question two, other than PLI, what are the countermeasures which urgently India should take for a short-term advantage?
Yeah, so I know I might not be very popular when I say this, but I don't think PLIs are a solution.
Yeah.
Because the money comes post facto.
Yeah.
Right? Our industries are large capex.
Yeah.
If you go talk to banks, nobody wants to fund you until you don't have a customer. And you don't have a customer till you're not qualified.
Yeah.
So you have to put some risk capital, build your technology out, qualify with customers, and then get into these contracts.
Right.
Also, like we've discussed PLI a lot with the Indian government for us. But anode has different requirements, cathode has different requirements, electrolyte has different requirements. So to come up with one scheme is actually very, very tough. So I think the intention is there to support the industry.
Right.
But maybe the government today hasn't identified what is the right way to push this. Again, my opinion as an outsider is that we need a customer, and that customer happens to be the US market in the next 3 to 5 years. So I think we need to focus on that. At the same time, it's good to bring awareness, and these kind of conversations raise awareness because like today, the discussion happening on rare earths and the government saying we're going to come up with the PLI, corporates coming up saying we will invest, every auto company having something to say about supply chain challenges.
Right.
So why didn't anything happen earlier?
Yeah.
Why didn't all the companies, all the auto companies go invest or say, look, I'll pay $5 more, but hey, you build a plant in India for me. They always wanted the cheapest thing.
Right.
And today you're in a problem.
Yeah.
So some way they also need to see way to de-risk and all, but definitely this rare earth challenge has raised awareness. Okay, what's the next thing that can cause a problem? That way the US is 4 to 5 years ahead in their thinking. They've seen it, policy is much more mature. So they're able to identify that, look, these are the way pockets, and the government is also able to fund, a lot of these initiatives to build supply chain.
Right.
I think, look, again, if I look at the ACC PLI, it was good. It asked for 60% DVA.
Yeah.
It was very clear that, look, we're going to give you money, but
Yeah.
slowly, please buy locally. But customers aren't interested.
Yeah.
They're happy buying from China.
Yes.
So the policy was good. Then it's up to the entrepreneur to comply and
Yeah.
build the ecosystem. That's what they gave them the PLI for.
Right, right. I mean, much before PLI scheme, I was talking to one of the potential companies which were thinking about cell manufacturing, and they said if we can arrange investments, if we can put up the facility, and if we can sell also, then we don't need such scheme. But at least, you know, PLI, if you look at the momentum before PLI and after PLI, one is the result of how many companies are coming with what kind of capacity, but this actually brought a lot of awareness in terms of traditional manufacturers and unique startups also to focus on maybe that segment.
I think a PLI is good when you have a established industry and you want to scale it up, like electronics manufacturing and these things, right? So you have an incentive to double capacity.
Right.
I think these new industries where technology is a challenge and large capital is difficult. But at the same time, PLI losers also are very focused. Look at Exide, look at
Yeah.
Amaraja.
Yeah.
They didn't win in the PLI, but they're moving ahead.
Yeah.
So that India offers that opportunity.
Right, right. So, I mean, I just wanted to gaze a little more understanding about how this happened in China, maybe whether there was a PLI scheme or their focus was more on ecosystem development. What are the
Right.
differences between these two countries? Obviously, we need to learn a lot from them and then move, but how it got developed in China?
So in China, obviously, when from the top, the 5-year vision comes out
Mm-hmm.
and says, look, this is what we're going to do.
Hmm.
Funding moves
Yeah.
and these like contracts move.
Hmm.
So the government came and said, look, I think 50%
Hmm.
auto industry is going to move to EVs.
Right.
So multiple car companies came up,
Yeah.
names we've never heard of,
Right.
right? CATL started saying, okay, look, I need to start growing.
Right.
He went down and started looking at anode and cathode players. He started going down and looking at lithium mines and nickel mines. So he started pushing, saying, here's a contract, guys. And with his contracts, people could get funding. People were growing. Now, okay, in some cases, it got overstretched also.
Yeah.
So, not denying that. But immediately, everybody moved. And when they talk about this new, they identified this as new energy sector. I had gone to visit a cathode company in China,
Okay.
and they said, look, 5 years old. He says, we are now shutting down the factory. We built a new factory in another province. I said, but the factory looks perfect. Why are you shutting down? He says, look, 5 years ago, I promised this investment. I got all this land free. I got the buildings free. I got half power rate, half payroll paid. Right? Now it's run out. Now I'm no longer competitive.
Oh.
I've gone and signed up with a new province and built a new factory.
Oh.
And a more efficient factory also, because
Yeah.
furnaces have become longer, equipment sizing is better. I said, but what happens to this investment? He goes,
Yeah.
so you move on. So that growth is also happening that way. And that's why overcapacity also comes up.
Yeah.
But that vision to come down and everything percolates, and especially there's a lot of risk capital.
Yeah.
In India, like that risk appetite is not there. A bank will not fund you. So if I'm a startup
Yeah.
and I want 100 crores,
Yeah.
it's very difficult. That's unfortunate in India.
Right.
You need much more risk capital, and this whole industry, whether recycling or battery materials or cell making, it needs a lot of capital. Unfortunately, there are a lot of failures,
Yeah.
but it needs risk capital, and credit has to go to the people who at least tried.
Right. Right. Vikram, how is your recycling plant linked with the entire strategy? I just wanted to know a little bit.
Yeah. So I look at every core business
Yeah.
and say we have to make it circular. That's like within the group, we look at that.
Hmm.
So on Epsilon Carbon, for example, we are India's third largest carbon black manufacturer. We are building a tire recycling plant
Yeah.
also
Okay.
of 300,000 tires. We will take the recovered carbon black, put it back into our carbon black and make a greener carbon black.
Oh.
So I look at our battery material business the same way, where we will build large anode and cathode facilities.
Right.
We will recover lithium, recover graphite, and feed it back into our process.
Right.
Now it's very difficult to time
Right. Right.
all this.
Yeah.
So I look at every business has its own individual trajectory, individual growth, and hopefully in 4 or 5 years they will complement all each other, and
Right.
there'll be that synergy. It's definitely happening on the Epsilon Carbon side. and I'm confident it will happen on the battery material side.
Right, right. One more important point. I was looking at the some of the data points about the company, and you say that you are 100% non-Chinese anode manufacturer.
Yeah.
So, uh, what it is like? How can you say that 100% non-Chinese? Number one, and second, maybe we can talk about, um, if you look at the entire value chain of schemes. So the China plus one is a buzzword, right? Wherein it was expected that India is going to be the large beneficiary of China plus one strategy. But in traditional auto manufacturing, it has happened, but in a limited capacity. Do you think that can happen in a much more capacity in this business?
So when I talk about us being non-Chinese,
Yeah.
it's about the whole IP we have generated
Hmm.
on our anode business and cathode through acquisition.
Hmm.
So we have more than 30 patents already, and another 50 are in the pipeline.
Right.
Right. So I think again, owning that IP,
Mm-hmm.
owning the design equipment, the process know-how, it's all ours. We have no technical partner who's feeding us and telling us what to do.
Okay.
This is our know-how from the ground up we have
Mhm.
developed.
Mm-hmm.
I think it's hugely valuable.
Which means you have put a lot of money in R&D also.
Yeah, we have more than 30 PhDs working with us.
Hmm.
Like I said, we have a cell lab,
Yeah.
material lab, and the pilot plant and the commercial plant,
Right.
all in one location.
Hmm.
So it's a large facility, a large investment on the ground that
Nice.
we've done to get to this point.
Hmm.
Um, Coming to your other question
China plus one.
on China plus one, I think the global market, industrial market, has moved to what was 20 years ago and now.
Yeah.
Right? I think Maruti Suzuki was a big instigator for the auto component industry
Right.
in India and built it as partners.
Mm-hmm.
I think with
Yeah, partner. They brought.
they really partnered with auto component companies, taught them, brought in efficiencies, brought in volume, kind of like the Chinese
Yeah.
industry I was telling you, where he comes and says, "Look, I'm growing, start
Yeah.
growing.
Yeah.
I will need you. For
Mm-hmm.
me to succeed, I need you." And I
Yes.
think that collaboration happened there.
Mm.
I think over time, the pricing coming out of China, India became very comfortable sourcing
Yeah.
cheap from China.
Right.
So that's a challenge. But again, I think when I look 10 years down the road and I say, where can this industry develop?
Yeah.
Like for me, it's obvious it's India,
Right.
because Japan has its challenges, Korea is expensive to build in, US is expensive to build in. So certain part of the value chain has to happen in India in this battery materials. Say the processing industry,
Yeah.
mining might happen in Africa, mining might happen in India in the future.
Right.
But the processing industry in India, inherently, we have a huge advantage
Mm.
and we understand it,
Mm.
as a chemical industry.
Thank you very much for joining, and I look forward for such more discussions.
No, thank you very much. Thanks.
It was really amazing conversation with Vikram Handa, and we were able to discuss about Epsilon's journey in the graphite-based material and upcoming journey in terms of their cathode manufacturing. We talked a lot about supply chain restrictions and how India can position, at least in the synthetic graphite-based anodes in India. Also, we talked about supply chain challenges in general and how a plant can be built in India and United States and in an integrated manner can tap the customers. Eventually, we talked about different export restrictions coming out of the China, United States, restrictions on India in terms of the import duties, and identified the opportunities how India can excel or an Indian company can excel by leveraging the current situation. In the end, we talked some details about the PLI scheme and what India can do better. Obviously, given the challenges for making a unified policy which covers anode, cathode, electrolyte separators, and all part of the battery value chain. And then in the end, we talked about how a company can build 100% non-Chinese anode in India. And overall, please keep watching the episode. Stay tuned for more episodes.